Hello, today we are learning about base conversion. What are bases? Bases are basically ways we represent numbers. Take the common number system for example. We call this a decimal system or base 10. Why is it base 10? What does that mean? Well, if you look at the current number system, you notice that there are only 10 unique digits that represent every single number. We have 0, 1, 2, 3, 4, 5, 6, 8, no wait, that's 7, 8, and 9. Combinations of these numbers make up every number manageable, like 10, 11, 123, and 2147, 483, 647. Same 10 digits every time. Okay, well that's cool and all, doesn't seem very useful. Well, trust me, it is. The most important number system in computer science example is base 2. Taking what we know from base 10 having 10 unique digits, we will say that base 2 has only 2 digits, 1 and 0. Why base 2? Because computers at their very core are made up of signals that are either on or off, and we represent these with 1 as on and 0 as off. Okay, but how do we make bigger numbers like 7? Like, I have a 7 on the screen right now, but how do we store that and represent that? Good question. To figure this out, let's look at a number in the base 10 number system. Here we have the number 1743. Let's break this up into multiple parts. So we have 1, 7, 4, and 3. So if we expanded these numbers to their corresponding values, we get 1,740 and 3. Now let's divide the bottom number by the top number to look for any patterns. Whoa. This looks very suspiciously like powers of 10, namely 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0. Okay, so maybe we can infer that each number is multiplied by that base to the power of its position. So let's take 111 base 2 for example and apply this idea. Oh, so that little 2 by the 111, that is how you denote the base of a number. So we start by multiplying the rightmost 1 by 10 to the power of 0. Wait, no, hold on, that's wrong. Since we're in base 2, it would be 2 to the power of 0, which ironically is the same answer as 1. And multiply that 1 by 1 and we get 1. Alright. Simple enough. So let's go to the next number. So this would be what would be known as the first position. So it's to be 2 to the power of 1. So we have 2 to the power of 1 equals 2. Multiply that 1 by 2 and we get 2. Alright, still simple math. And now the last position we get 2 to the power of 2 equals 4. 1 times 4 is equal to 4. So let's add these together and we get 7. Alright. So this means 111 base 2 is equal to 7 base 10. But what if we wanted to go the other way? What if we wanted to start with 7 base 10 and then go to base 2? How would we do that? Well, let's do that then. 7 base 10. Let's start by, since we're going to base 2, we're going to divide it by 2, which gives us 3.5. Wrong. It's wrong. Don't do this. Wrong, wrong, wrong. 7 divided by 2, I will convince you, is 3. Remainder 1. This remainder is highly important. Always keep track of these remainders as this will determine your number at the very end. So we have 3 remainder 1. Well, 1 can be represented in base 2, but 3 cannot. So let's continue on. Let's divide 3 by 2. We have 3 divided by 2 is equal to 1. Alright, so we have 1 as our answer, and then 2 remainders of 1. All 3 of these numbers can be represented in base 2. So, if some of y'all might notice that, hey, we have 3 ones here. That was 7 in base 2. So, but what order do we put them in? So, we have the 1 that we got as our answer, the remainder of that one, and the remainder of the first calculation. So, 7 base 10 equals 111 base 2. Boom. The last calculation, the last answer and last calculation you get will be your first number, while the first remainder you've got will be your last number. So let's practice with some other bases. So we have 31 base 10, we want to convert it to base 16. Alright, so we start with 31 divided by 16 equals 1, remainder 15. Well, both 1 and 15 are less than 16, so we know that they can both be represented in that system. So we have 1 as our leftmost number and 15 as our rightmost number. That can't be right. Because the whole point of bases is so that we have one symbol to represent a number. But here we have 1 and 5, that's 2 symbols. So, we have to come up with a new system. What system is this going to be? Well, let's follow this. We're going to leave 0 to equal 0, 1 to equal 1, all the way through 9. But now we have 10, 11, 12, 13, 14, and 15 to deal with. So, what do we do with those? We'll go to something that most people have as common knowledge in the back of their head, the alphabet. So, whoa. You're asking us to put alphabet into this? What is this, like actual math? Yes. Yes, this is actual math. So, what do we have for 10? So, well, 10, let's assign that to A. 11? B. 12? C. 13? D. 14? E. And 15? F. Note that capitalization does not matter in this system. Capital F is the same as lowercase f. So, now that we have our system, we can go back. So we have 1 and 15. Well, looking at that table we just made, we can see that 15 is equal to f. So we have 1f. So 31 base 10 is equal to 1f base 16. I hope you found this video useful today, and now I'm going to give you a chance to pause the video to try these practice problems before I reveal their answers. Answers will be revealed in about 5 seconds. I hope to see you all next time on my next Intro to CS video.